Hello, everyone. Welcome back to Jetson AI Lab Research Group. Thank you so much for joining us. Today is Wednesday, May 29th. So in the past couple weeks here, I'll just start sharing my screen, or I guess I already am. You already see it. We've been integrating this Hermes model trained on top of Llama 3, and it was trained with OpenAI-style tool calling that looks like, let me see if I can find the template for you here. It looks like this, the dictionaries for it. You might see it better just in this type of description. So this uses like JSON-based formatting as opposed to like the Python style function calling that we did before, and it's much more advanced in terms of like the arguments, and it uses these like JSONic templates that it can do more than just these function calls. It can do all types of different JSON constrained inputs and outputs. But I have a couple functions in here for it, like just like getting the weather forecast, different cities, different times, turning on and off stuff in Home Assistant. I have like a little basic setup going here with it. So let's see if we can get it to do anything. Hey, can you turn on the lights? Ah, turned them on. Can you turn off the lights? All right, okay. So let me walk you through what actually happened here. So I told it to turn the lights on. It then made this like tool call output, right, in here, which the function that I defined for it in the code is right here. Sorry, if you guys can't see this or it's too small the text to read, just let me know. So I implemented this little wrapper function around the Home Assistant REST API here, this one, just to like really easily control the states without getting into the full Home Assistant stuff. And basically it just takes the name of a device, like an entity in Home Assistant, and the state that you want to set it to. And I just told it like which ones are available. I'll make this like dynamic when I have more time, but then it just goes out and like probes that and returns back like the string that it's set. So, and then in the description there, it automatically generates all this info in the desired JSON OpenAI format that it was trained on. And when you ask it to, it does this tool call argument like it defined in its model card here, right? And when it does these tool calls, there's code in a optional like post processor that finds that, runs it, adds another response to the chat, and then continues with the bot generation so that it responds another turn. So this time we are now not in like back and forth two-turn style chat. There's now like the agent can do multiple responses without you interacting with it. I think up to 10 it defines. It's called like a self-recurring agent, and it feels like much more like an agent now, which is cool, right? And you can see again, it inserts the plug that it thinks I was talking about, puts the state in there. These are like the arguments that it defined that corresponds with the code of the function here. And then essentially I extract this dictionary and expand it as keyword arguments into those Python functions. And it calls the function like directly. So you don't need it to integrate your own functions into this. You don't need to do anything more than put this little like bot function decorator on your function, and it will automatically register it with the system put it into the system prompt here and allow the model to call it. And it works much better than just the Llama 3 basic one that I showed a couple meetings ago. Let's see if we ask it about the weather here. Hey, what's the weather today? Pittsburgh. Okay, so it should have already known that we were in Pittsburgh because that was up in the system prompt here. And like you can like remind it that it already knows, but so it took what I told it, then put that into the argument, called it, got it back, and then responded about it. So another nice thing about this is I'm not really like curating the responses in the functions. I'm just returning like the full JSON back from the REST APIs or whatever that we're querying. It's very raw data that it's able to use. For example, like when I returned from the Home Assistant, I didn't even like filter this really. I just gave it all this stuff and it's able to discern like it's on or off. Same thing for the weather description here. I think like the more data you give this thing, the better it acts. Hey, what's the weather tomorrow? San Francisco. Okay, so in this case, it asked again about the location. I think that's because of like how I have in this case, you have to like write really good documentation for this thing to really understand it. I think I might need a little bit better docs describing like if they don't give you a location, use your previous one that you already know from the chat or like things like that. So it's not always asking you like what location do you want the weather for? Because at first, when I wanted to test this was like it has a good ability to provide the arguments for you. But here, so this one, it's able to discern between calling the current weather function and the forecast based on like, do I want it tomorrow or Friday or like next weekend or whatever? And it just returns the next 5-day forecast, all the data for the next 5 days. It returns in here, and then it's able to extract that and like answer questions about it. And again, like we're not making like a weather bot here or anything, but that's like low-hanging fruit to experiment with like the abilities that this thing has and like what arguments it's able to fill in, what calls it's able to do, things like that. So this seems pretty promising. It's still not perfect. We could still fine tune it on things, but I'm going to integrate it with like the vision system next and start making more things with it. It feels much more like an agent now with like the multiple responses and the tools it's able to do and call and things. And interestingly, Nous has another model called GenStruct that this one creates training data sets, synthetic training data sets for agents defined on some like agent profile that you make. And then it creates, I think it makes the data set that they use to train this thing. So we can take a look at this and do further fine tuning. And I also want to start collecting the chats from this so that it can like learn over time. For example, if it gets it wrong or it like already knows the location and forgets things, you can just tell it and it's like, oh yeah, sorry, and then it'll like do what you ask. And perhaps by recording those chat transcripts and collecting them for fine tuning, it will be able to, you know, distill those desired behaviors over time. So, and chatting it with it verbally is much easier than like, I don't want to spend all day typing with this thing, but I'll like chat with it with ASR and stuff for collecting things. Okay, there was something in the chat. Carrie, is there now a definition of agent? When do we cross that agent threshold? That's a good question. I think in my mind, it's like either multiple models are involved or it's going out and doing something with RAG or function calling, or you see like these multiple turns going back and forth. For example, I'll share a screen again here real quick. So to make this all work well, and no, there's not like an industry term for agent, but I think it's more complex than like just a simple back and forth chat. Essentially, you were having a much more unstructured like chat going on. So the past month or so, I have been revisiting like the internals of how the chat state is stored in this chat history. And now there's like a separate class for each chat message. So this type of thing is what enabled us to basically do not just your normal back and forth like user chat, where you might just go from one like person speaking to the bot to the person to the bot again. Now you can have like person, bot, tool call, bot, tool call, bot, back to the person. And this like open-ended chat message. Let me just pull up the docs. That'll be a better way to look at it than the source code here. This open-ended chat message format and stuff where you can just, and this is also very good for multimodal because these chat messages can be, you know, text, images, audio, whatever modality, and they can be any role. In this demo I showed you, there's the user role, the bot role, the tool reply role, which are defined in the chat templates for this, which are in another file. But there was a special template for this one that made it all work. And then that is further integrated with all of like the KV caching and the chat management. Because one thing you'll notice is like these chats are starting to take up a lot of tokens. Just in a simple back and forth, we were almost at 2,500 tokens there because the system prompt is so long. But by virtue of all the hard work that we put into like optimizing the LLM inference and like the KV caching and all that, like it's fine. And I think that's appropriate for the, like you're never going to really talk to this thing for more than like a minute or two at a time, I would think. And then it will like next time you re-engage, it'll start a new chat after saving that. Okay, Mizeko asks, those plugins for HNA and RAG can be run together at the same time. Yeah, exactly. Through those bot function plugins, like the weather and whatever, we're gonna run this all simultaneously. And the next thing we're going to be doing is like integrating it with the vision language model so it can ask things, or like it gets a table back from the vision language model saying, these were the captions from your video camera from the past X minutes or whatnot. And then it will summarize all that for you and say, hey, there was a person walking in the frame at so-and-so time or whatnot, or be able to change the query. Or if you're looking for like how many people are in the image, it counts it with alvit saying like looking for a person or whatever you ask it for. So that's really what I want to do next with this. And this demo was all about just seeing like, can it actually do this more advanced function calling? Since the last meeting, I've also been working more with the AWQ based quantization. And for that demo right there, I was using AWQ Tiny Chat backend, which I have working again in Nano LLM. So this past weekend, I got both the Hugging Face Transformers API and the AWQ API back working again in Nano LLM, because I was curious, like, what are the effects of the quantization? And with the AWQ quantization, that agent does perform better than just the base 4-bit. I think it's GPTQ based. So the AWQ, it takes a lot longer to do the quantization, and it runs a little slower, but we'll work to optimize that. We've got some like interns around now, which is great. So we're running a lot of these projects, looking at like the fine tuning and measuring the accuracy and performance of the VLM and the LLM on Jetson with the quantization applied, and doing more things that like we didn't necessarily just have time to do ourselves. And hopefully part of that is like integrating more of these plugins with the Home Assistant system. And right now I was just showing this using the REST API. It was not integrated yet into the actual like voice assistant infrastructure that Mizego's been working on, but we'll work to get that in there. The nice thing is like that was all Llama, and or like the Nous Hermes model, which I really like that Nous group, and we'll continue to work on that. But if you guys have any questions or feedback with like where we're heading with this, or like what we should work on next with these agents, it definitely feels much more like an agent now, because it's like calling itself and, you know, going back and forth. And how I do foresee this going is like there'll probably be multiple windows open in like the demo. One of the windows will be that controller LLM chat terminal, where it's just like running all the time, responding to you, getting messages from like the VLM agent or the smart home, the home assistant. When like events occur, it can send events into the chat. And then one for the vector database, and then another panel for the home assistant and like the vision system. So if you have like a 4K screen, you got like all that running. And Mizego, did you have another question, buddy?
Yeah, just a small one, if I could. I wonder, at some point, I suppose we would need to make a decision where and how the UI for the end user would look like. So I wonder if we tend more in the direction of having the UI as an extension to Home Assistant, or as a separate thing, separate service
Totally.
right now, as we have right now.
Yes, and I don't know if they have like a text chat thing in like theirs for their voice assistant. I think they've mainly been limited to voice, but it would be good to see that debug. Or okay, Mike says they do. Great. Yes, we can integrate with all that. And
yeah,
the way I run these with like multiple demos is like I just make like one iframe page that has like 4 of them, 4 quadrants going, and you can load that with whatever. But that's just for like our end. And right now I like to see all that debug info, like the tool calls it made, the response. But like in like the OpenAI app on your phone, you don't necessarily see all of that. But like we do, we want to see that in like our debug view for things and see what it's actually doing. But I feel like we have like a lot of the pieces now that we need. We have like controller LLM. It still takes some like tweaking, and I don't think we're gonna be able to get away from like eventually needing to do like a LoRa or a fine tune on things. The important thing will be, can we naturally collect the data that we want to tune it based on like just saving the chat transcripts from going back and forth with it, and when it messes up, you verbally correct it and like move on. And by virtue of doing that, can you teach it or use this like gen struct model to do it? We have the real-time VLM. We have the real-time multimodal vector database, which that should be really interesting for this too, because what we want to do is like every second or minute, or when like a salient detector detects change or optical flow in the video feed, it like saves that frame and clip embedding into the database along with its caption. And then Llama will be able to search over those and be like, hey, did the mailman come? It will search the vector database for the term mailman. And since it's all clip will find the pictures showing mailman, and then we'll insert the metadata attached to that back into the chat. The metadata will include the timestamp that image was added to the vector DB. And since all that JSON data there is in the chat history, just like we saw with the weather APIs and the verbose Home Assistant return information, it will be able to say, hey, there was an image with a mailman at so-and-so time. he was here at 12:54 p.m. You're welcome. You know, so that's how I see that, like, video search function working, which I think is like really what we all are kind of going for here, because being like edge AI and everything, we want to integrate all these different modalities into the system. But yeah, we have all these pieces. We just kind of like got to continue working on it, and it still takes a lot of time, because like every time you add new stuff, you got to restart it, and it like takes minutes to load and like messing with things. But it's like a lot easier now, and the model itself is like quite powerful, which is a game changer. Okay, we have a question from John Outshap. Would Hermes Llama 3 function call into Vila or Lava for image captioning on a single? Yes, an AGX Orin would definitely have enough memory for this. It does now. We're not even like approaching that, because I'm still running it in 4-bit. And that's the other thing. Like, I might, with the controller LLM, I might up that to 8-bit, or start messing around with higher bit quantizations just to see if it really matters. Like, I feel like that the controller LLM is pretty important, that thing's smart, right? So we might want to take the performance hit and run that a little slower to have it have more intelligence. Whereas the VLM, we just want that to run as fast as possible, and that can be with like 4-bit. So we'll have to start messing around with that more. The bigger question is for Orin Nano, which has always been our remit, and this is like to get this full up multimodal agent running on Orin Nano and only 8 gigabytes of memory. This is much more challenging, right? Because this Hermes Llama 3 is an 8 billion parameter model, and it will fit in Orin Nano that, and hopefully with speech and stuff, which we will talk a little later. We now have Whisper in TensorRT, thanks to our teammate John Welsh, who is a TensorRT ninja. Got all of that to run in there, and now it only takes like I think like 500 megabytes of memory, as opposed to previous ASR was like 3 gigs or something. So and then we did Piper also, which was like 400 megabytes of memory or something. So in theory, yes, we could do this like controller LLM plus ASR plus TTS on Orin Nano. The problem is like getting the VLM to fit in that too. I'm not very confident about that, because like there's lots of people on the forums that I've been helping get the Vila 3B VLM running on Orin Nano, and it like barely fits. And like, yes, it's only a 3B, but it also has the SIGLIP vision encoder on there, along with all of like the video streaming stuff, and like that pushes the limits already of Orin Nano. So it's like you on Orin Nano, you can do the VLM, or you can do the controller LLM and speech stuff, but not both at the same time, I don't think. But even so, like for an introductory AI platform anybody can get, I think that's like pretty good actually, what that's able to achieve. But then on the Orin NX, that has 16 gigabytes of memory, that can run the whole thing. And Seed Studio has that nice recomputer that I'll have to set that bad boy up and mess with all this. And I think that thing costs like $899 or something, which again is like, we're trying to make this as approachable as possible, but that's also like not too bad when you consider like what this is all able to do and fully open source. Okay, let's go through some of the questions here. Randy, Llama 3 70B with AWQ working in text. Yes, okay. That's good. And AWQ is really good quantization. Sanghan from MIT Han Lab, he has an appointment at NVIDIA too. So we have a group there that they do Vila also. Okay, and AWQ is one of the highest quality quantizations out there. It is a little slower. And Randy, I'm curious what performance you were getting. Typically, we see around 5 tokens a second on AGX Orin with 70B. Okay, Romeo's question. How many parallel requests can... Yes, okay. So one thing, like these APIs do batching, okay, like MLC handles batching and stuff, but I always have that turned off and just do like single request I've not really, like a bunch of this stuff, it could handle multiple requests, but they would not be running in parallel. I just do single generation, like it's all threaded and asynchronous, but it does not do batching. TRT-LLM excels at batching, and I continue to work on that. I've actually been quite busy working with the TRT-LLM team to get that support all running on Jetson, and we have it running again with like latest one and are preparing the release for that. That does batching and like in-flight handling all that, so you can have requests coming from everywhere, and it like automatically assimilates them and like handles it. That would probably be how we would handle batching. But yes, there's nothing to prevent it now from handling the multiple requests, but it would not be batched at the same time. The other thing that in my experience with like batching of these really high-end models is like on Jetson, we're already at like 100% utilization, right? Doing the batching is not going to really improve efficiency nearly as much as you would see on like a cloud-based architecture that has like way more compute on it, right? So it can be fine that we just have these parallel requests that aren't batched. And if they're running all at the same time, then it would just like reduce the performance. There's not to say any limit. The interesting thing will come into play. Let's say we have the persistent closed loop VLM running all at the same time as the controller LLM. Like, how does that all work together? Will we need some higher level scheduler to like, when the user talks to the controller LLM, that takes priority and like flags the VLM generator to slow down? Because one nice thing about this low-level integration I have with all the APIs, like if you dig into the Nano LLM model API backends, you'll see like we do things at like the token level and dig like right into the low-level APIs for this. So I can tell the LLM, hey, just stop at this token for a while we're doing this other request, and then you could start again after that. So we could implement some like priority queuing system in there. And that low level integration is also how we're able to do all this like KV cache management, and that becomes way more important for like long context lengths and the video streaming VLM stuff. Okay. Another item we had on the agenda today, Chitoku has been working more on like the RAG samples. So obviously we're trending more towards like RAG, function calling, multiple agents. We've like, from where we've come, we've like really built this up and have all this stuff. And we wanted to teach people more about doing RAG, working in OLLAMA, Llama Index. So Chitoku's been doing great work making these like RAG samples and has some stuff that he wants to show you. And on one hand, we have like the whole OLLAMA support, which is like very easy to get started with based on Llama C++ and GGUF models. And then Llama Index is built on top of OLLAMA, so you can do easy RAG with OLLAMA and Llama Index. Then on the other hand, for like full-on multimodal, multi-agent, high performance, we have like the Nano LLM stuff that hopefully between those, like you get the best of both worlds with like full-on speech and everything. So Chitoku, if you're there and want to like screen share your latest stuff that you've been working on, that would be great.
Sure. Okay. Yeah. Let me try to. Hi. Do you guys hear me?
Yeah,
Okay,
yeah,
cool,
we hear
cool.
you.
All right. Let me share my screen. Well, unfortunately, I just broke something, so I'm going to just like use my
Okay. I
recorded
know that.
video.
All right.
Yeah. So I recently added this package called jetrag. Not sure if that is a good name for this package, but it's basically Llama Index to do all the RAG, and then finally Streamlit. It's a Python package library to easily make an interactive web app. So all those combined into one package. So people can build this Streamlit-based application pretty easily. Streamlit, if you guys don't know what that is, it's again a Python library. This is great actually. I fell in love with it. It makes everything easy to if you
It
are
is
making
nice.
web app.
Yeah.
There are a couple
And
other things, but like I think this is like the lowest. I mean easy to enter sort of thing. But anyway, so what I got to what I managed to show is this application tentatively called Jetson Copilot. An idea is it would be cool to sort of run an LLM that has access to all the Jetson related documents so that it can teach you how to use Jetson itself. Sort of like, yeah, funny kind of.
it is.
But
Oh,
of course,
and you would think it's like highly motivated to help you build its
oh
robot.
yeah, of
Great.
course, right? I mean, one thing is you can actually characterize this character. I mean, yeah, assistant by just providing a system prompt. Um, so yeah, this is actually pretty fun and a lot customizable. And the great thing is that I can even like create this in like from this is even like my very first like iteration of this software. It only took like 100 lines of Python code, and then you get to have it's going to come up a nice UI, a decent web app that actually lets you do all kind of things. Here I'm
Can you
selecting a
full
large
screen
language
that?
model.
Can you
Oh,
full
can
screen
I?
that video?
Is this better?
Yeah, that's good. Oh, it looks good. Yeah, you're right. The
Yeah,
UI is. It looks like
yeah.
Windows 11. That's funny.
Yeah,
Yeah,
for some
that's
reason it
nice.
has a default sort of theme, and then this is a little customizable. So I added NVIDIA greenness and then customized the icon and stuff. But anyway, so this is RAG. So I'm actually sort of upgrading this app right now, but the initial version, it first like just scans through this directory and then goes through building the embeddings and then index so that the large language model up here that I selected, Llama 3 in this case, can be augmented with the initial retrieval based on your prompt. So
This
this
is
one
okay.
I
So you
try
can
to
set
make
the LLM there and the embedding model that you want.
right. And then of course this embedding model or running an embedding model can happen offline. So okay, so this is what I came up with. What was that Jetson run? Funny thing is, Llama 3 itself actually knows quite a bit about Jetson. So I needed to select something that, it didn't, scan through. It didn't find the answer in the training time of Llama 3 itself. So I go a little deeper. What IP address does it get assigned when connected to the PC using USB device mode, such. And this is a little tough question. So yeah, I wanted to see how it. By the way, the way I was giving the message history was not efficient. And then this is actually a bogus answer. So this is actually a bad example of unsuccessful result of retrieval lag. So this is not good. But yeah, when I got to demo this in the internal team of NVIDIA Jetson team, yeah, people were pretty amazed, and then they had found pretty practical or useful already. This is just doing RAG. So of course, fine tuning is better. Maybe we can try Lola, or all sort of spectrum. And then RAG is a raw hanging fruit. But yeah, this is already pretty useful and extendable. So I'm interested in putting this out as a package. I'm going to define the jetrag package a little bit with a sample like this. And also, we are thinking of pushing Jetson Copilot as just an independent open source project so that people can, not only interact, make use of this Jetson knowledge, but they should be able to also sort of build their own, knowledge, do the RAG. For example, if they are to make a kiosk terminal based on your shopping mall or store or product, for exhibition or something like that. This may be already a working solution for some of the people. So I'm hoping to put this out pretty soon. Hopefully, definitely before the next round of our meeting today, on Wednesday.
This is great, and it looks like the code you have up. This is in Jetson containers now, and I built the containers for this, and the code is very, very simple to use. So you guys can go off and do your own co-pilots for whatever situation you're in, and like give it text files, PDFs, HTML docs. We did have this working at one time with like this question we use for the IP address is the one we always try to like stump it on. And so there is some things in there with like introspection of the RAG that it adds and injects. Like I think through this UI, you don't actually see what it added in, but hopefully there's some mode where you can see the actual RAG, and that's why in like our more custom nano LLM stuff, like I just always have that in there so you can see, oh, put this part in there because it might be responding to like the wrong thing or whatnot. But from a framework perspective, this is real nice to use, and it's built on top of Ollama. And NVIDIA continues to focus a lot on like RAG embedding models. We released an embedding model last week called NV-Embed, which is now first on the worldwide leaderboards for large embedding models that are used for text. So this is all like our text-based RAG solution. You can see this being used in like smart factories or whatnot. You like have a PC or an industrial terminal on the factory line with like all of the manuals and docs in it, and like the people there can like be asking the system about that and other things. So yeah, and then the Chitoku, you were mentioning it processing the whole context, length, history, and stuff. And so when I talk about like the smart KV cache and all of that, that is basically what I'm meaning there. When it's saying like thinking for a while, the reason that in the previous demo I showed you it thinks much less, and I always wanted to respond in like less than a second, is because we pay a lot of attention to how we're handling the previous KV cache states, the chat, and because now the chats are getting long, and that's all very important here. You can see it like going on, and you don't have to reprocess all that context, and it's balanced with like the memory the system has and everything. But I think this is very promising. I'm interested to hear others' opinions on that. We have basically like a dual strategy here. One for like when you're like just getting started, you run on your first LLM, want to get RAG running, use Llama Index, Ollama.
Well, start with the Ollama, right?
Yeah, start with Ollama. When you make the jump to like real-time multimodal speech, VLMs, function calling, all of that, we have the higher performance stuff available for that, and hopefully between those two, there's a nice onboarding procedure for everybody. And we're continuing to do tutorials and stuff to make it easier and bring support for Orin Nano, updating JetBot and the robotics platforms and all that stuff. So it's a big project to make this easy and accessible and approachable for everybody, which is the whole point of this group. What we're doing is to bring this like intelligent open source AI to the world in a way that anybody can use it and deploy it into the field for like actual embedded systems. Cool. And any comments or questions on this or feedback on like the direction that we're heading with things you want to see, things you need.
I know we got some sort of feedback or like a request earlier on our forum for text-based RAG, and that's the reason why we created some of the tutorial, packages and stuff, and then we are going to later come out with tutorials. But yeah, I just wanted to sort of see how many people are interested in, you know, this kind of text-based RAG application. Okay, we got some. Yeah, cool.
We got some. We'll take that as positive.
Yeah.
All right.
Okay.
Thanks,
Cool.
Chitoku. It'll be exciting to see where we're at another 2 weeks with this. I like having this research group because it does push us along. It's like there's like we've now working in like an agile development method for like the next 2 weeks. But it is going to be summertime. There are people starting to like take off vacation a bit. There's not like Llama 3, Phi 3, all these models. It's seemed to slow down slightly on the model release front. Thank goodness. So hopefully that gives us more time just to be heads down and really push to do this integration of all these different pieces, right? Like again, I think we have like the building blocks we need now for this system. Time to like buckle down and just get them all working together nicely. It's like a lot of tweaking of like all of it's prompt engineering basically. Which is not easy at times to figure out. And what I've realized is like, we're at the point now with it where we have all like the generation capabilities and the performance. And if you're like banging your head against the wall, like, why won't this work? Why can't I get it to work? A lot of times it's just like on the model side, model wasn't trained for it, needs fine-tuned, or like the quantization needs to be higher or things like that. So that's where we're getting at this point, because we've proven that if for things that are in the domain of like the training data set, it's like no problem. It like gets it straight away, right? But when you like we're doing all these like corner case stuff that it wasn't really, then we're like struggling with it. The answer is just to fine tune it a bit, and then it just works like magic, which is way better than like having to like hack your way out of it, or like those functions I provided. We basically don't want to have to like curate the APIs and the function calls for it. Just give it the raw stuff. Give it all the raw JSON data and the requests. Like that News Hermes model, it had they enabled it just to write and execute its own Python code, and I like disabled that on my side initially, but it would go out, it was writing code to like search Google itself and like go off and like do that. So that's all in there. I could add like Google search to this thing, and yeah, the sky's the limit for here. But I guess my point being, like, if it feels like it's not intelligent enough, then we need to look into like the fine tuning and the lore. And another project that I was looking at again recently is from the AWQ Songhan's team again. He has the thing called POC engine, which is a tiny fine tuning engine that can run on embedded systems like Jetson. Okay, so in theory, we could do this where like you're collecting chat histories and you can like fine tune it on board even to figure it out. So hopefully by the next meeting rolls around, I can mess around with that a little bit. I think this whole self-learning aspect of the agent is very important, not only through RAG, but also like some LoRa. And I know Nigel, I see on the call, he works with the Jetson IGX team and has done fine tuning on vision language model at least. Okay, we had one more topic on the agenda for today, which relates to Orin Nano, actually, like we were talking about. And I'll screen share again here. And I don't know if John Welsh is on the call. John, are you there? He had made this. John does like the torch to TRT, and it's done a lot of like the initial TensorRT work for YOLOs or different models. He did NanoOwl, he did NanoSam, all those VIT stuff. Most recently, he got Whisper running in it, which is 3x faster, and I think it's 30% faster than Faster Whisper, which is the previous fastest one. And the memory, I think I quoted earlier, yeah, so it uses around like 500 megabytes of memory for it, and it has a real simple API for this. So I did get the container built for this. It's on Jetson containers now. It's integrated. I tested that I can build this into Nano LLM, and I was hoping to have that already integrated, but we'll be working on that later this week. So then there'll be a plugin for Whisper TRT in Nano LLM, just like there are plugins today for Riva and Piper TTS and stuff in Nano LLM. And then you'll be able to use this on Orin Nano. So I think the default ASR will be this Whisper TRT, and the default TTS will be Piper. And then we'll have ASR and TTS way faster than real time in less than 1 gigabyte of memory. And in my initial test with this, the Whisper quality was very good in this, and it ran very fast. So like we see on the benchmarks here. So this has been a long running thing for us to like try to get this all optimized down and running all in real time on like the Orin Nano platform. So yeah, hopefully this is one of the last pieces to the puzzle here. We'll get this going shortly, integrated with everything. For now, I think on the Home Assistant side, we're fine with Faster Whisper. Mosaico, I think that ASR container uses Faster Whisper, and like that's still Faster Whisper is good too. This one is like 30% faster, but they're both like pretty good enough for that. So yeah, and then we could make our own container for this. That's another thing I wanted to look more into, is like making your own Wyoming containers, so that when Mike and Nabu Casa define additional Wyoming protocols for like vision language model captioning or things like that, we are more able just to do them. And also like want to start on like the ROS side of things for the robots, because that's like our ultimate goal here. Like, we want to have smart home, and we want to put it on robots, and we want to do more ROS nodes and work with like the Isaac Ross team, much in the same way like a lot of our work that we're doing here in this group and on Jetson containers and stuff, that feeds the Metropolis teams and other ones to go into like production with. And we want to do that with Isaac Ross too. So we have a Nano Al node for Ross, but we want to make like LLM nodes and like all of that stuff too. Hey Martin, what was your question, buddy?
Hi. My question was like, how many people are actually using like Turtlebot 4 or Create 3 robots?
I don't know how many they are. I have a Create 3 right over here that I got last summer. I got as far as getting Ross 2 on it to talk to like my Jetson, and then this whole LLM craze hit. And since then, I've been working on this and the agents, and I'm only now finally starting to get like back to where I could conceive working on it again a year later. I don't know exactly how many people are on it or whatnot. The Create 3 is made by iRobot, and it is a nice platform. It has like ROS 2 pre-installed on it, and so like it runs ROS 2. Your system can run ROS 2. You send like the twist messages to it to like control it around, and again with like what we have going on with like the JetBot and NanoSoar, Create 3. I also have the Double 3, which is like a telepresence robot on wheels, and like other like ClearPath robots, whatever. If it's like ROS based, not like you could do this with any robot without ROS, but like we just like want to make it easy for anybody. We just want to make it like drop in, essentially, that you can add this LLM brain on top of your nav stack or whatever it might be.
Yeah, I already did some work with the Create, like at the Ethernet connection, because
okay,
you only use this Wi-Fi, and that's just that,
And Chitoku figured this out also. He has a guide for how do you, if you have your Jetson on board the Create 3, running the hard Ethernet link to it, and then setting up the correct Ethernet interface routing so that ROS, the onboard ROS controller doesn't use Wi-Fi instead of the Ethernet. So like, yeah, and like he's on days just on like this stuff, you know.
That frankly
Awesome.
may need some updates. So yeah, please contact me at least. Yeah, if you ever find any more issue on it.
Awesome. So since you're on, we can talk about like the direction we're heading with the Home Assistant stuff, because that does continue to like gain traction, and we're like getting more into it. And I've noticed like on the Home Assistant Reddit, they're really active, and there are a lot of people that are doing like these AI agents. And I've been posting more, like telling them about this project, and the response has been really positive. And they're like, wow, we like love this group, and are like all about this. So on one hand, there's lots of people experimenting with this, presumably on like their x86 systems. On the other, here we are on Jetson. How do we like bridge that gap between these communities and like start to enable them with things? I think a lot of it is about the Home Assistant supervisor work that you've been experimenting with. So if you like, what have you learned so far in your experiments with that? Does it seem plausible to get the supervisor running? I've been keeping an eye on your like PR and like working on there.
Yeah, it was slowly evolving over time. So this attempt was to just containerize using Docker, just everything, right? Because we would like to have like nice approach, just to host everything with Docker, well, just like with Compose.
Yesterday when I wanted to do the Z-Wave thing, right? Yeah. It was like, okay, it wasn't bad. I filed the Home Assistant docs. It's like, if you're not using Supervisor, go run this other container yourself, which for me is like fine. But then again, that is now, I think it was 4 containers I had running for that demo that I just showed you. There was the Z-Wave container that has its own web UI, the Home Assistant container, the Nano LLM container, and the Riva container for all that. So then, like, yes, we could do a Docker Compose for it, but if the supervisor can spin that all up, I guess my point was the Home Assistant community is very vibrant, very large, right? And before we like turn everybody onto this and they have a bad experience managing their own Docker systems and everything, yeah, what is your take on that? How to best proceed from here?
Definitely, I think that we can just port the installation process to the host machine because we cannot achieve the full compatibility using the Dockerized version. So it just requires too much, system resources for like UDEV, managing devices, etc. So it's quite a lot of things. So my plan, which I also shared on the pull request, was just to create an easy install script for Jetson devices. We can observe other scripts for other machines on the wild. So partly I will just use the known approach to that problem. But yeah, I think it's doable. It's not yet converted by me to having separate script, but yeah, it's still work in progress.
Okay, it's good, and yeah, it does seem like it is at least plausible. You at least got it starting to run, so it could be. It would seem promising, and again, like yes, the officially recommended method is currently like keep the official Home Assistant running on your Raspberry, on your other server through their official thing. Jetson will be the AI server, whatnot, for your home or on your robot, whatever. But there are obviously people that are like, why do I need like extra boxes for this? They already, you may or may not have a Jetson, but like yes, point taken, and that's what Paulus from Home Assistant said first too. Is like just run Home Assistant.
That's not an issue. You can just follow the current approach, which we have just Home Assistant core for many folks. That would be enough to use, right?
Yeah.
We could just integrate those Wyoming containers manually, and it will work. I have a running supervisor together with the UI and everything, and I was even able to host a separate repository with add-ons for Home Assistant, and tried that with my GitHub account. I added a new repository. I also was able to install add-on from Docker Hub. So I proved that it's working. So just a matter of installation of the host on the host machine. That's all.
Yeah,
it will work.
That's great, and I think I much appreciated that you spend time on that. And look, I understand, like we all have our demons and struggles with like build infrastructure for projects of this scale, and spend for like basically I get like 1 day a week or so, maybe like things clear up on the weekend, to actually work on new feature development. In this case, it was all that like advanced templating for the Nous Hermes, and like how to get that all like multi-generation, and it was a departure from before, right? But like just to like get all the build infrastructure set up to support all that, the containerization. And there's a very apt message here in the chat from Sina about struggling with like the Dockerization of all this and the container. And look, like I get it. I totally understand. I remember when we first started using containers in like 2019, I was like, what is this? I don't want to do it. Now, it's like I can't imagine not. And once you get more comfortable with like, okay, the container is just a glorified virtual environment that you mount all your stuff into, and then it all behaves the same. So when it all blows up or whatnot, you can just wipe it. You are correct. Like they're very large. I think the Nano LLM is up to like 25 gigs or something. And but it's because like these libraries are so huge and advanced that run like the LLM inferencing, just like the model side. The software stack for what we're doing here is enormously complex, actually, which is like, if you want to like scream into the void about like Jetson containers and everything, like I get you, believe me, like we've all like the test scripts in there and everything, they all are there for like a reason. I know a number of members from this group, they've gone out and be like, I don't want to use this. I get it. And they go up, they come full circle way back and be like, I get it now, Dusty. You can't pip install anything without it uninstalling everything. And like, that's why I run my own pip server, right? With custom code that blacklists packages from the PyPy mirror and everything. So like, unfortunately, like, yeah, it's all there because of this like state-of-the-art multimodal edge AI stack that we are running. And again, like you don't need to, you can just pick Ollama, and we're working with Ollama maintainers just to make that as easy to install as possible, even without container, right? Or like the pip wheels, the reason that I have that pip server now, you can just install those wheels outside of container. The container systems are just a glorified build system for those wheels, essentially, that are their own. Like some of them take like 8 hours to build with CUDA acceleration and everything. And now we can also install like the latest. So for this TRT LLM work I'm doing, that's with CUDA 12.4 and TRT 10, which thanks to the flexibility of our Jetson container system can like spin that environment up no problem and rebuild PyTorch and the whole stack. We're doing like millions of lines of like complex CUDA kernels and stuff here to make all of this work. So yeah, the DevOps infrastructure around this is really no joke. That has taken the bulk of our resources. But yeah, we did hit the max layer limit and then went back and redid. And it's always in the back of my mind, like, can I add one more thing to the container and get it? But again, like the reason that we have all these different packages in Jetson containers is so you can pick what you want out of it. Because when we first started Jetson AI Lab about this time last summer, It was like, oh, we had a Docker file for Ooga Booga text generation web UI. We had a different Docker file for Stable Diffusion web UI, and they did everything for it. But then it was like, oh, we're getting like so much stuff here, and like, what if this person doesn't want this or whatnot? So then we made it modular, so you can just pick and choose what you want. And I think this comment was with like Nano LLM in particular, or like the terminal containers. Let's say the ones that you actually run. They're getting like ginormous, right? And these are why I know is like this is not just our problem. Is in the NVIDIA enterprise containers, they're also very large like this too, and other people's are, and it's kind of pushing the limits of Docker microservices and things like that, because like the Gen AI software stack is just like that big and complex when you integrate like speech, multimodal, vector databases, multiple inferencing APIs. It's just like, yeah, it takes several days to build, fully automated if nothing goes wrong. So that's just where we're at with it. If again, like the reason we have this group is like discuss the direction we're heading, feedback on things. I want to hear from you guys where you see like things going with like the agents, what you need, what functions you want integrated. Like Mizega, where do you see things heading from here, or what we should be working on, or what support you need? I'm happy to discuss.
Well, I really like it, all that you showed us today, and I recognize this as a big step forward. Yeah. But I wonder at some point, and I was touching the UI of this agent, controller agent. At some point, we need to integrate with Home Assistant. And I'm speaking into deeper integration, not only the REST APIs, but the UI. Yeah, so I just think how to approach that if we still want to use Nano LM together with its tools. Should we do that with Wyoming or any other API? I don't know yet.
That's a good question. With the UI in particular.
Yeah.
And the reason that I did this own like the UI in there, it's just HTML5, JavaScript, WebSockets. I do have plans to go back and make that modular, so it's not just one HTML file. There will be different JavaScript things you can run, but like create web chat, create vision language model widget, those different container widget cards that I have that you can drop down. And I have identified JavaScript libraries that will let me make those like drag and drop and like resizable and like all that. Okay. And you'll just be able to say, oh, the agent has the VLM on it. The agent has the LLM or the controller thing on it. So like spin up these widgets in the UI for it. That said, like I'm not like a front end web dev here. I want to make it as easy as possible to use these. We will document the WebSocket protocol that's used, which is very simple, right? It's just like JSON messages back and forth, which is nice, and those get connected with the Nano LLM plugins automatically. So you could implement it in the Home Assistant web UI natively, which is probably much preferred over like to keep consistent with like their CSS and everything. And I know some folks have started to look at that, and it is just coming up like, hey, I want to integrate with the Llama Speak agent and do like the WebSockets thing. And I believe as some folks have started to get that to work. So yeah, it's just like as this becomes more mature, we need more docs for things, more integrations. Meanwhile, it's like I can barely keep up with like just like the basics of like getting us there. So it can be difficult at times to make sure everything is like refactored nicely. And but I think in terms of like the approach of like how I'm doing those web UIs is pretty sound. And the whole reason was like back a year ago when I started this, like I wanted to talk interactively with Llama, be able to interrupt it less than 1 second audio to audio latency gap. And like, no, Gradio and Streamlit and those ones were not geared for that type of continuous back and forth. They're not doing WebRTC, real-time video, all of that stuff. So that's why I went back and just like, okay, we're gonna do the highest. That's kind of my thing with like the Nano. Let's give you the reference implementation of the lowest overhead, highest performing one, and then from there, if you're welcome to go off and integrate that however you want, or use other APIs.
Yes, that sounds really great. So, quick question to Mike. If I'm not mistaken, maybe I need to go deeper into this, but I suppose that we could just create another add-on for Home Assistant, just to wrap it around NanoLM and expose like a new tab on the Home Assistant UI, where we could just display anything for start initially, like NanoLM interface, right? And under the hood, we could just use the APIs straight away from the Home Assistant, right?
Yeah, you could add a tab to the dashboard, and just do it that way. There'll probably be better. I don't know what the plans are to extend the dialog box that we have right now. It's already showing its age because as the LLM spit out Markdown, it just displays plain text. It even strips the new lines out, so it's just a mess.
Okay. Yeah, well, and I get that too. Like every time I have to update the filtering for how does that code formatting. All of that is like regex and stuff. So I get it. Can it just show like an iframe, or like how does it actually work under the covers for integrating that?
Well, for what we do, it's just some div that pops up and is just showing text bubbles.
Okay, we can do that now in the interim. I do want to get this like properly integrated where like we've talked about, there'll be like a virtual camera sensor with like the VLM, and it will all be properly configurable through Home Assistant. But I think for now in like the interim, while obviously like everything is moving at light speed here, we're all struggling just to like keep up while taking full advantage of this like amazing opportunity to make these agents, right? So like my vision in like the short term for like this summer essentially is like, yes, we can add a tab to Home Assistant, just show like the view. We can use the Home Assistant REST API to like easily hook into stuff. But in the longer term, we want to make sure that like these new APIs that you're defining for the Home Assistant agents, the voice agent, the vision agents, things like that, we're like properly integrated into the system in the right ways,
right,
going forward. But as a playground to like actually make the agents and iterate quickly on them as to arrive at like the final solution for the best ones, we can just like patch in however quickly as possible to
in this upcoming release, the June release, there should be this LLM tool API that's being added. So what this does is it's going to add for the OpenAI and the Google integrations first, since they have actual tool function calling. This would work great for Nano LLM as well, though. But what you can do is you can create an LLM API that can be picked in the config for your agent in Home Assistant. And what this does is just return a set of tools to the LLM that it can then do whatever it needs to, inject into the prompt or something. And we have a predefined one for assist, which gathers up all of the available intents and gives those as tools. And then it will, when you give the tool call back, it will call the intent and do what it's supposed to do. And it's smart enough it only shows the tools that actually are meaningful. So if you have no media players, it doesn't expose media intents, etc.
Yes. Okay. Good. And I remember we talked about that before, essentially doing RAG with the function calling, and we can do all of that too. And I think I will be very interested to look into this, how we can connect like our models, even though like Hermes one isn't it's like an open source model. But the thing I'm curious about is Yes, probably you're developing this against OpenAI and ChatGPT, so like that all just works. How do we make sure that the way you are exposing these interfaces can be melded to support the templating that other models require? So like, yes, this Nous Hermes fine-tune was aligned to the OpenAI function calling style, but it might have some minor differences or quirks in there. And how do we like adapt that to work, or like whatever model comes out? It's not really nano LLM. It's like what open source models are freely available to, and I'm just like RAG and function tuned models are like a thing right now. So those will continue to come out. So yeah, I love to take a look at this and see how we'll best integrate it. That's great. We're all kind of like we're gonna warp speed on this all at the same time, and we'll all get there.
Just to clarify, it'll be the integrations job, like the Ollama integration, the OpenAI integration. It's their job to take the list of tools and put it in however it makes sense.
And format that. Okay. Yes.
Yeah, it's just that the tools are nicely standardized, and custom components can define their own tool API that exposes other tools. It could be, you could expose services, you could expose some other web service. It doesn't matter. It's just that the two are decoupled.
Yeah. Obviously, in the scope of things, like we'd love just to like expose the whole API to it, and because there's so much in Home Assistant, right? That's like the vision, just to be able to like, hey, you have these APIs you can hit with all these entities and values and things. But yes, we'll essentially need to do RAG on that since it's so large. Or if we can get an even larger like a code llama with 32K context length, then maybe we can do it all. The other thing I'm interested to look into is, in addition to this controller LLM, running like an anomaly detector LLM, because these LLMs are very good at classification of text, right, and JSON. So if we just give it the like event history of like streaming into the LLM and have it say, hey, detect anomalies or aberrations, or like summarize my energy usage, whatever, and like tell me every like hour or whatnot, if you see things running, that'll be, so we'll have like a perpetually running VLM on your video feeds. We'll have a perpetually running LLM on your event history and things. You'll have the terminal that you can speak to that runs when you're actually talking to it, and then like a vector database going of all the data that it collects from like your video streams that you can search and query on. So that if you, in terms of like the post-processing event filter, I know we've talked about this whole notion of like the virtual sensor and whatnot. And hopefully we can look into that a little more as well. So yeah, sounds good. I look forward to seeing all that. So yeah, if you guys are cool with it, we'll continue with that. Much like we have this Ollama and Nano LLM approach for like easy versus like high performance, we'll continue with like the Home Assistant. We can just patch in how we need to for now while things are still in development, and then also be looking at like your official APIs going forward to like fully support those, so we can all get to, and we do this at NVIDIA too. We have our whole Jetson community driven open source code effort here that like we're doing right now, and then there's like they take that and like productize it, and it lags behind a little bit, but it's like we've discovered a lot of really awesome stuff through that too. So it's this whole like open source development model really pushing things forward. Okay, we're I always say like we run an hour 15 on this meeting, and we're getting up there, so we'll wrap up soon. Let's take one more question here. It's an open question for me. Can the quantized 8B be? Yeah, it is something we're starting to look at more, is like the effects of the quantization, and that is totally like benchmark. You can go and see that today. It's not specific to Jetson. With Thor, I think the main deployment would be with FP8, because that will have Hopper introduce FP8, so Blackwell has FP8 as well. I think you'll see a lot of models run it at FP8 on Thor. But yeah, it's gonna have a lot more compute to handle all of that. And again, like if you don't want to use int for quantization, we have like MLC will do 8-bit, 6-bit. You can do XLlama EXL2 up to like variable bit rate. You can do Llama C++, AWQ. If you have concerns about effects of quantization on quality, use the AWQ backend, because that has like the best quantization, because the quants take a lot longer to run. It's activation aware quantization is what AWQ stands for. And the data sets it runs it on actual data sets. It takes like overnight to run on my Jetson for like I think for like an 8 billion parameter model, it takes like a couple hours to do. And yeah, but in general, I don't, even in production for like the highest quality stuff, I don't think anybody really runs at FP16 even. But that you can do that now. Like I have Hugging Face transformers back working again in there, so you can run it at FP16 if you want and see. To put in perspective, so like when I was testing this again over the weekend, Llama 7B through transformers runs at 10 FPS or 10 tokens a second. Through AWQ, it was at like 30 or so. Through MLC, it was at like approaching 50. Okay, so that's the type of curve you're looking at here. And this is all dependent on, like, it's really up to you. How much performance do you need? How much quality do you need? If you're just doing text chat and RAG, probably you want the slowest, highest quality one. If you're doing real-time VLM, you want the fastest one. If you're doing the like controller LLM agent, maybe the middle one. The cool thing is with all these APIs we have integrated, you can just transparently change them. You can be running Hugging Face alongside AWQ, alongside MLC, whatever quantization level you want for your performance. But okay, with that, we'll start wrapping things up. Unless there's other questions, of course, happy to stick around. So we normally go 2 weeks. I have a conflict on the next Wednesday. So if we could do Tuesday, June 11th, that would be great. If anybody has any major things against doing these meetings. Okay, sounds like Tuesday is cool. We will do Tuesday, June 11th. I will post this recording of this meeting either later tonight or tomorrow. But until then, let's stay in touch on like the forums and LinkedIn and stuff. I will be continuing to work on like this function calling and like integrating it with the vision agents and getting it smarter. In addition to like, I have a lot of refactoring of like the agents that I want to do and like the web UI stuff. And like, I know it's all in there. And these agents have gotten more and more complex, and I keep adding code to them. But that, yeah, we do need to take a step back and like refactor that and make it all easy to use. But yeah, if you guys have any issues or feedback in the meantime, feel free to hit me up. Thanks as always for joining this meeting. This is always great. I love doing these, and I feel like this group is like really driving things forward. If you look back from where we started past GTC and go and review the videos and everything, we made like significant progress here. It doesn't just happen overnight, but we are persistent as we've been for the past 10 years with Jetson. So we will get there on this. And I really appreciate your guys' support. It means the world to me. So with that, I'll let you guys go. We will see you again on the 11th of June in the summertime. So, all right, take care, guys. Thank you so much.
Thank you, everybody. Cheers.